Okay, our regular C4GC, for all the new members, that's the Core C++, C++ Core Guidelines Corner. And today, Yair Friedman is going to give us our corner. Yair is a secure software professional at Intel Jerusalem. He's also a modern C++ evangelist, as I suspect many of us are, and has been coding in C++ for 27 years. I suspect that's more than most of us. Yair is also a Monty Python fan and always expects the Spanish Inquisition. Please, thank
you. Hello. So our subjects for today, the Jizzle spam. Okay. So before we start, how many of you know what is the Jizzle coding security guidelines, coding guidelines? Okay. How many of you went to the website and read at least one of that guideline? And how many of you changed the code according to a guideline, at least one line of code? Okay, more than zero, we are good. I hope that will improve. So, what we'll see today, first we'll start with the feature of C++ I dislike the most. Then we'll see guideline F24, whatever it means. From the color view and from the color view, there will be live examples and the summary. So, what I dislike most in C++? T star pointer. Why? Because C++ is usually a strongly typed language, and T star gives me little information on what is behind that. And here are some questions we won't refer, the answers are there. So, who owns the memory? Can I do it? Do I need to allocate, deallocate? Can it be null? It's a pointer. A pointer can be null or not null. And if it's a pointer, does it pointer to one object, or maybe we have an array here that has been decayed into the pointer? Usually we can identify the arrays because that's the way arrays are most of the time referred in functions, structures, whatever. You get base pointer and the size, but the big problem is those are two discrete pieces of information, and there is no way that the compiler at compile time or even at runtime can determine if the size is correct or incorrect, and this is a big problem. Personally, as a security guy, many of the security problems arise from that single issue. So, we have guideline F number 24, use span-T or span-PT to designate a half-open sequence, which is exactly what we see here. So we have a function which get a pointer and a size and a plain array of a certain size. Don't use plain array unless you have a very good reason. And there is later on a valid call with good size and invalid call with bad size. So let's see how it works, and I really hope that the font size is okay. So that's our program. What we saw, and now it's going to be more challenging because first of all it doesn't want to go. Okay, apologies for the Windows guy or for the Linux guy for this abuse. And I'm sorry that I don't know how to increase the font size here. So you have to believe me. Okay. Here I compile it with all you can see. So it's error, wall, extra, everything standard 17, everything that you expect. The compiler is silent, and when I run it, okay, first you see a good print, and the second call prints beyond the bounds of the array, good for hackers, knowledge about what exists in the program's memory behind. So we have from the GSL library, GSL span. Here we choose the integer, and it gives us the array that encapsulate into one object the array without paying the price or without paying a considerable price. And how we can use it, span, you can just leave the call as it is, or give it just the data type, or if you know at compile time the dimension, you can give the compiler dimension. And I think we can skip the live demo here because Adi is short of time. But you can see that what you can see is for the color of the function, unless you specify the dimension, the compiler and the GSL library doesn't give much protection. So if you call with the wrong, if you call with the wrong, of course you don't pass the size, so there are less possibilities to be wrong. But if you pass the dimension and A doesn't match the dimension, in this case the program will go out of bounds of the array without warning. In this case, since you are giving the dimension, and if the dimension of A is known, then you will get GSL, I think, throws an exception or calls terminate.
So you can't send a subset of the array?
You can send a subset of span. Span has a multitude of well, not multitude, but quite a few functions or methods that you can create a subspan from a span.
Oh, but you have to first create a span and then pass the subset. You can just...
Yeah, but you can do it on the line, on the fly. So you don't have to...
I think I have a question.
Yeah.
In this case, A is actually not a pointer. It's a literal array when the size is known in compile time.
Yes.
So that's why it can actually check.
It can actually check.
Less than or equal to
right.
100. And that's why I guess the second line also works, because it knows it's 100.
But it knows that it is 100, but it doesn't know what to expect here. I don't know. I wouldn't expect this also to generate some warning. I would expect this to generate a compile time warning rather than a runtime warning. But currently, the Microsoft implementation, which is considered to the major GSL implementation, doesn't give a compile time warning. Okay, so let's back. How things are being looked at inside the function from the callee. So again, a vector and a pointer, and then question number one, you see a pointer. Can it be null or not? Well, with this interface, I'm not sure. So I put the line here in comment. And here I print the items of the array. pointer arithmetic rows. So this call is okay. This call is certainly bad. This one is questionable because the size is 0. So the pointer can be null. But what does it mean? This function will be okay with the third call, but it is not always clear. With span, our life is good, really good. Why? First of all, C++11 range loop. Cool. Okay, but there will always be those who say, I need the index. I want the C style loop. So there is a C style loop. We have a size here, and for some reason, which I didn't understand why, the index has to be of this type, but it might be compiling from if just for size. So I'm not sure what is the meaning of Gisel index.
Maybe for static analysis.
Maybe. Array operator. This array operator is checked. That means that it cannot, if you are getting out of band, which you will see at home with the examples, if you get out of band, you get either exception or terminate. So
each access you pay the price of the branch.
Each access you pay the price of the branch. Yes, it's a small price. It depends. Yes. Well, you can tell Gisel not to check. It's up to you. It's up to you. If you're willing to suffer the risk of getting out of band, then it's okay.
Doesn't it mean that if you can do the first loop, the range loop, doesn't it mean that it supports begin and end?
It supports begin and end. You have the iterators. And iterators are yet another kind of pointers that I dislike. So instead of passing a pointer, you can pass an iterator to somewhere in your span, which is okay. But there is an old Danish proverb that says every loop is essentially an algorithm. So that's the algorithm version of the same loop. They are all the same thing, yeah. But yeah, you usually don't want to do just pass over the span. You might want to do find if not, calculations. There are multitudes of algorithms that can be used. Yes? Gisel has, I think, 3 or 4 implementations. The implementation I showed you before, Microsoft header file. One header file.
Isn't
the internal implementation of the span, is it a container or a generator? In terms of generator, like
it presented a container interface. I'm not sure that it presented everything.
Not interface, implementation.
Implementation, we'll see.
Inside.
We'll see.
I have another question.
Yes.
Does it should we use std_array if we can, because std_array promises a lot of things?
Later. Okay. Now that I think this table answers both of your questions. So, well, it's not that thing. It's a bit more complicated because you have all the methods. But from data member point of view, that's all behind the span. The pointer and the size. Okay, and these are, in my opinion, the 3 data structures that you should use instead of CRA if you can. Strive very hard. Each of them has its advantages and disadvantages. Vector is the most flexible, but it allocates over the heap, although you can control it if you know how to deal with allocator. It owns its context, but copying is expensive, therefore you pass vector by reference.
The star is from mutability, I suppose.
The star there, yes. There are some small vector optimization, maybe yet another subject for later.
Move semantics is not a small.
No, it's not.
No, I'm talking about small vector optimization.
But small vector optimization.
This is
You
why
can't really do it for us to develop. That's the point.
another lecture.
It's forbidden
We are running
by
out
the
of time.
standards.
So yeah, I just put an asterisk so you know it's not always expensive. There are sometimes that it is logical to pass stud vector by copying. There are benefits, lots of material. I think can arrange yet another series of talking about it. And it allows to mutate your elements. Stud array, on the other hand, also owns in context, but not allocated on the heap, and doesn't allow you to mutate its element. Span is non-owning. Span is not owning. That's the minimum. No, you can't. I'm not sure. That's okay. So, but you cannot resize. You cannot change the size. You cannot change the size
Determined at compile time,
at compile time.
unlike the vector.
Right. And yes, because it's not on the heap, it's on the stack. Span doesn't own its element. Cheap, so the semantics is value semantics instead in GSL span, and mutability is possible. If you want, you can create a span of const element.
The passing style is only by value? Can I pass it by reference?
Yes, but it doesn't make sense. You usually want to pass by value. You want to preserve the value semantics. That's one of the things that in C++11 onwards, reference semantics are very difficult.
Like smart pointers. No, but
It's the same. It's the same size as the
Yes, don't ever pass smart pointer by const reference. Unfortunately, you say
There are cases. There are cases where you want to do that.
okay.
And that depends on how much you care about your stack lemma. Because if you really care about
if
your
I
stack
care,
memory,
I don't
you pass by
pass it by
reference.
value.
You pass it by reference, yeah. Because it's smaller.
It's widely done.
Yeah.
Pass by reference.
Okay, so we are done.
Thank you.